Hello and welcome to Module 10 in our C language series. Today our session is going to focus on the preprocessor. So what exactly is the preprocessor? It's important to remember that it is used automatically by the C compiler, doesn't require us to do anything as programmers, but it does allow us to send instructions to the compiler through our source code. Also important to remember that it's not part of the C language, so it does benefit us by expanding our programming environment. So let's look at some of what the preprocessor does. Something called initial processing that it does, which includes reading the input file into memory and breaking it down into lines, depending, of course, on where we place our carriage returns. And GCC accepts ASCII sequences like line feed or carriage return or a combination of both. Continued lines are merged into long lines. So this is best explained through a very short program. So you can see here I've put in a backslash, right? And this would be considered a continued line, right? So when the preprocessor transforms this code, this will be read as one instruction. So it will detect the continuation by the presence of the backslash and then merge these two lines into one. So now if I run this, you will see that it will run as normal. Also note that when I use, or when I want to rather display a backslash, I need to put two of those within quotes. So now moving on. Comments are replaced with spaces. Coming to now the preprocessing operations, these would involve inclusion of header files. We've already seen this. Macro expansion. What are macros? Simply put, they're constants. We know constants have values associated with them. We would use the name of the constant in our code, for example, and macro expansion would be the replacement of that name or the constant name with the actual value. Macros can also serve as functions, as we will see later, and macro expansion also applies there, because although we would use a name, right, in our code, that name would be replaced by the preprocessor with a fragment of code. Conditional compilation, we've seen how to conditionally execute code using the if-else construct. There's a similar construct which we can use to conditionally compile our code. Talking about line control, this is more kind of appreciated if we have, for example, two source files and then we're combining them into a third source file before we give that in for compilation, right? So the line numbers are going to change, and of course we look at a visual later in the session to explain that. Diagnostics are to do with errors and warnings. Important to know that except for expansion of macros, all operations, or all other operations I should say, are triggered by directives. So now let's take a look at some of the preprocessor directives. We have hashtag if defined, hashtag if not defined, hashtag else, hashtag elif, which is short for else if, all related to conditional compiling. Then we have hashtag include, which we used before. We have hashtag define, which is to do with defining macros, as we will see later. We have hashtag undefined, allowing us to undefine a macro. Hashtag line to do with line control. Hashtag error to do with diagnostics. Hashtag pragma. Now there are pragmas that could be useful to the compiler. Like for example, you've written your program for another compiler and then you're trying to use GCC, but we're not talking about those here. We're talking about the pragmas useful to the preprocessor. So let's take a look at an example. So here we are just using string cat, as you can see, to join these two strings. And of course, if I run that, you will see the strings join together, right? Now I can use hashtag define. And of course, we're going to discuss hashtag define in detail later. So now we can replace strcat with cat or cat. And this will do the same thing, right? So if I run this now, we should see the same result, right? But now, if I do something like this, right, and I introduce a pragma which says poison strcat, meaning I don't want the program to use strcat anywhere. Then if I run this, I get an error saying attempt to use poisoned string cat. But if I move this line above, which means I am using the hashtag define before pragma, then I will still have this particular command work. Right? So putting the pragma after the hashtag define does not make any difference. But if I put it before I use the hashtag define to define a macro, for example, then of course I'm going to get an error, right? Then we have hashtag endif, again to do with conditional compilation. Important to remember that each directive must be on its own line, no semicolons for any of these. Let's talk about hashtag define. Defines an identifier and a string. Like in the program we just saw, the identifier is cat, the string would be strcat. Defines names for magic numbers. Well, what's a magic number? We'll see shortly. The string will be substituted for the identifier. Right? So strcat, as we saw in the example, is the replacement for cat. Macro name would be the identifier, in our case cat. Macro substitution would be the replacement process itself. Talking about convention, it's common practice to use uppercase letters for definition of macros. You could have a separate include file where you could club all the macro definitions, or you could place them as a start of the file. The macro name can have arguments, and this is how we could use macros to replace functions, as we will see shortly. No semicolons to be included. Use of a backslash if longer than one line. Important to remember that when we use macros to replace functions, there is an advantage in terms of increase of speed of execution of our code, because remember, we are not executing function calls, but at the same time, there's a downside, which is increase in the size of our program itself, as we will see again shortly. Hashtag error is used for debugging, forces a stop to compilation. Very important, because hashtag warning does not. So with hashtag warning, you could just put in a message to the user. So let's say, for example, the user is or has included a library that is obsolete. You can use a hashtag warning to indicate to the user as such, and include the name of the library that the user should actually include. The format would be something like this, and of course error message would include the error message that we specify, but it could also include other information that the creator of the compiler would like to include here. Now write some code, but before we do this, let's go take a look at a short program. And here you can see we're using hashtag define, we're using a macro, right? And we're using that magic number here, value is 10. And of course, you can see the macro name put in wherever we need to use 10. So at the end of preprocessing, max size would be replaced with 10, and that's macro substitution, right? So now if we run this, just a simple program printing out the values of counter, you will see it runs just like we would have a normal program. But with macros, we could also do something like this. Now you can see we have a macro with an argument, right? And that argument is used to determine whether it is even or odd. And in our code, we could have a statement here, that's a printf statement, and we are invoking that macro here. So what will happen at the end of preprocessing? This will be replaced by this fragment of code, and now you can see how the size of the program will increase. Right, so we run this now, and then you can see we get the appropriate messages depending on whether the number is odd or even. Okay, moving on. Accept name, designation, salary of individuals and deductions. Maximum salary is 50,000. So we can use a hashtag define for that. Ensure that valid data is entered for salary. So let's now go to code blocks and start a new file. We start with hashtag include stdio.h and then hashtag include stdlib.h and hashtag include windows.h and hashtag include ctype.h. So all the header files we need. Hashtag define max salary, and that will be 50,000. We have three functions: void enter data. We want to save that file on disk, so void save data, then void display data. We have a structure for our employee, and that would have char name of 30 bytes or 30 characters, char designation again of 30 characters, int salary, right, and int deductions. Put in a variable name for the structure. Let's call that emp, and we're going to have just 3 for testing. You can increase that value later. We need a handle type variable. That's going to be wstdout, and we need a coord type variable, and that's going to be dest coord. Why we need these, we will see a little later in the code. Int main, and all we need to do here is call those functions. So enter data, and then save data, and display data. Now we can proceed to define our different functions. Start with enter data, and we start by initializing wstdout equal to get std handle, and we need to pass that argument. If you recall, standard output handle. We need some variables in counter to count up to 3, and then we need x coord and y coord. These are going to keep track of the cursor position, right? And why we need that, again, we'll see as we move along in the code. For counter equal to 0, counter less than 3, counter plus plus. And what we do is every time we're entering a new employee's details, we clear the screen simply by calling system cls, which is the Windows command for clearing the screen. Now what we'll do is, remember, when we clear the screen, the cursor will be positioned at coordinates 0, 0, meaning 0 for the row and 0 for the column, right? So we'll say here dest coord dot x, that's the column, equal to 0, and then dest coord dot y also equal to 0. So those are set at the top of the screen. Now we can proceed to take in the information. So printf name, right, and then ideally we should be using fgetS because getS is deprecated, though of course we needed to know how getS works, right? in terms of reading from keyboard and writing to file. But now we'll use fgetS. So fgetS, and we need to provide the arguments, which will be emp of counter dot name. Need to specify how many characters. Let's say 28, and the file pointer, which in our case is a standard stream stdin. F stdin. Next element or next piece of data that we need is designation. So printf designation. And then again fgetS, right, m of ctr dot designation, and you can pick that up just from there, comma 28, comma stdin. And of course we can just paste that f/stdin here, right? Now we need to move on to the next piece of data or piece of information that we need, which is salary. So printf salary, and here we say cannot be greater than 50,000. Right, so we're notifying the user as such. Now, what if the user actually enters a value greater than 50,000? So we need to check, right? So while one, and within that loop, x quad equal to dest quad dot x, right, which is currently 0, plus 26. How did I arrive at 26? If you count these 1, 2, 3, 4, 5, 6, 7, 8 for the colon, right, and then 9 for the bracket, etc., you will get 26. Right, so 26 will position the cursor exactly here, and you can change that later on if it is not exact. So 26, right, and we'll have y quad equal to dest quad dot y. Remember, that's the row, so that will be plus 2, y2, because remember we have name and designation, 0 and 1, 2 will be salary, right? Once we've done that, then we can use scanf here, scanf. Now remember, this is integer, so we need to use ampersand emp of ctr dot salary. Now we can just paste in the f' there, and then include our check, right? So if emp of ctr dot salary is greater than max salary, right, then what do? We need to reposition the cursor, and this is the reason we are using windows.h and we are using x coordinate and y coordinate. We are going to reposition the cursor at the same point for re-entry of the salary. How do we do that? We will say here dest quad dot x equal to x quad, and then we use set console cursor position, providing the arguments, of course, which will be wstd out, comma, dest quad. Hope you're with me. Now we have set the column, we need to set the row, right? So here we can say dest quad dot y equal to y coord, and then again set console cursor position, passing in the arguments wstd out, comma dest coord. So now we have the cursor positioned, right? And we can continue. Okay, so that finishes our if. Else, what do? We just printf deductions and we accept the value for that. Scanf %d, comma, ampersand m of ctr dot deductions. Right? Now we check again if m of ctr dot salary, right, minus m of ctr dot deductions is less than 0, then what we'll do is we'll say printf net salary cannot be less than 0 and continue. Right, so that will go back into the loop. Else, we can printf net salary percentage d backslash n, comma, and here we can say m of ctr dot salary minus m of ctr dot deductions, right? And remember, this bracket is the end of our while loop, so we need to break out, right? So break. And the last statement in this function, remember that's the bracket that finishes that function. So before we end that function, we will just return. Right? Now that function is done. Next function, void save data. And here we need to use file pointers. So start with file *fp and then int counter again. We have our if statement to check if fopen returns a null. So if fp equal to fopen, and we need to provide a file name here. Let's call that m detail, comma, that's in write mode. If that's equal to null, then what do? We need to exit. So printf error opening file for write \n and exit 1. Okay. If that goes through, then we can start writing our data onto file. So for counter equal to 0, counter less than 3, counter plus plus, and within this loop we check first if Remember this from the last session. If star emp counter dot name, that is if it's not equal to null, then we check if f write now. Remember, we're writing onto this ampersand emp of ctr, comma, size of struct employee, comma 1, comma fp not equal to 1, right? Then we say printf error writing to file \n, and we can exit, so we can actually have a block of code here which ends here, and of course we can exit, because remember, we don't write. If we go to display, there's going to be no data, right? When we return from this function, remember, we are calling display data, right? So we need data to display, so we'll exit. There's an error, right? Now all we need to do out of this for before we return is fclose fp and return. That completes save data, and now we need to define display data, right? Here again we need file star fp and int counter, and here we say if fp equal to f open, and we need to open that file for read now, emp detail. You can put in whatever name you like for the file, but of course you need to make sure that it's the same for write and the same for read. Read equal to null, and again printf error opening file for read and exit 1, right? If it goes through, then we can proceed to display the contents of the file. So for ctr equal to 0, ctr less than 3, ctr plus plus. And here we'll check if read, and again we need to provide the arguments. So ampersand emp of ctr, comma, size of struct employee, right, comma 1, comma fp not equal to 1. I hope you recall from the last session that with fwrite, normally the return value of fwrite is equal to count. But with fread, the return value may not be equal to count if, for example, we reached end of file, or if there's an error and we need to check for both. So here we'll check if feof of fp, then return. Otherwise, if this is not equal to 1 and it's not feof, there could be an error. So printf file read error. Out of this if statement block, we'll print our details. Printf name %s \n, comma, emp of ctr dot, you can just pick up name from there, and similarly the rest of the information. So designation %s \n, comma, m of CTR dot designation, right? Then printf salary %d \n, right, comma, m of CTR dot salary, and printf deductions %d \n, comma, m of CTR dot deductions, right? We can also print out the net salary, printf net salary %d \n, comma, m of CTR dot salary minus m of CTR dot deductions. Okay, and that completes this function as well. We just have a return here, right? Okay, so now we've finished defining all our functions. We can run this code. Okay, there's some problem here. Exit 1, we should say that, right? Need to enter the details. Now, what happens if we enter a value greater than 50,000? You can see it comes back to that positioning. Enter it again, and now you see it goes awry, right? So how do we sort that out? What we can do is in enter data within this while loop, because remember this is a loop that is executing as long as we are entering a value that is greater than max salary, right? And here we are adding 26. So you see why that cursor is going awry. So what we can do here is we can bring it back to the top of the screen, right? And we can say here dest coord dot x equal to 0, and then dest coord dot y equal to 0. So now we bring it to the top of the screen. So then this should work. So let's run it again. Enter the information. Let's enter something greater. Comes back. Enter something greater again. And you see it comes back again. Right? Okay, now you see that we don't really get a chance to see that data displayed. Of course, we're going to display it again, but you could have a sleep over there, right? Which would pause the screen for a bit and then proceed. Also, you can see here I've got name and designation, which means there is the absence of an F flash somewhere. So let's check that out. Deductions, we don't have an F flash. Right? And while we're at it, we can add that sleep here. Sleep 500. We already have included windows.h. right? So that should be fine. That's very short, less than a second. Now let's run that. So enter the data. Designation. Right, so you see that paused for a bit. Enter another piece of data. Let's try again. Entering a wrong value, you see it gets positioned back again. Try entering a wrong value again, it gets positioned back again. And the last one, let's see. And there's the data nicely displayed. Right? Moving on. Hashtag include. The compiler reads another source file. So we've seen how we include stdr.h, for example. The file name can be enclosed within angle brackets or double quotes. So what's the difference? If the file name is enclosed within angle brackets, the search for that file will happen in a special directory as indicated by the creator of the compiler. If the file name is enclosed within double quotes, though, the search for the file will first happen within the current working directory, and if the file is not found there, then there'll be a repeat search conducted treating that file name as if it was enclosed within angle brackets, and therefore the search would happen within the special directory as indicated by the creator of the compiler. Conditional directives, we have hashtag if, hashtag else, hashtag elif, which is else if, and hashtag endif. Important to remember, there's an implementation specific limit on the nestings that we can have with these ifs and elifs. So let's now go take a look at how we can use these. Right, so I'm going to go back to that first program. So here we're going to say hashtag if max size is equal to 10. Then we compile this entire block of code. Otherwise, we don't. Right, so we put the hashtag endif somewhere here. Right, so currently max size is defined as 10. So if we run this code will run as earlier, right? But if we change this value now, let's say we put in 20, you see how this gets grayed out, right? So now if we run it, we have nothing because we had specified that this needs to be compiled conditionally, right? What we can do is have an else here. So hashtag else, and we can have a message there. So now if we run this, you'll get that message. Right, so see how that works. You could also have an elif. I could say here elif, and here I can say max size equal to 5, right? And I could copy that code here so that I execute the same code. Right, and here we'll have hashtag else. So now if we change this to 5, you see how this code gets highlighted and the rest is grayed out. So now if I run this, you see I get those first 5. Right, so I hope you understood how that works. Moving on. write code to define the currency sign of a country using conditional directives. Okay, so let's go back to code blocks. And we start a new file. Hashtag include stdio.h. Hashtag define. Let's have UK as 0. Now we say hashtag define the active country. Let's say Spain, right? And we have int main. Now we'll use hashtag if. So hashtag if the active country equal to US, right? Then we say char currency equal to USD, right? elif, so hashtag elif the active country equal to UK, then we'll have char currency equal to GBP, right? elif, right? So we are done with US, UK, Canada, Spain. Hashtag else char currency equal to INR, right? And then of course we have endif. And here we can say printf active currency is %s, comma, and we can just print currency, right? So now if I run this, active currency is 0, right? So you see how that works. Moving on. So as we know, if def is the short for if defined, if and def is the short for if not defined. Important to note that both hashtag if def and if and def may use the else statement, but not elif. So let's see a little demonstration of these two in that first program we have. So here I can say if def max size, right? Then do this. Now I can't use elif, right, with if def, so we're going to delete that and we'll keep the else, right, and the endif, of course. So we have max size defined there. Let's run this. And you see we have those first 5 numbers. Now, what if we use if endif? So we'll say here, let's move this up there. Right, and we'll say here 5 and then as 5, and we'll comment this out and change this to if endif, max size. Right, so you see how this code is highlighted now, and of course this one is not. So now if I run this, you see that still runs. So that's how we can use if defined and if not defined. Moving on. Hashtag undefined will allow us to remove a previous definition of a macro name, allows macro names to be localized, you can say, to sections of code that need them. So let's go and look at how we can use that. And I can say here, let's reinstate our macro and reinstate max size there. And we change this to if defined, right? So that executes. And we leave that as is, right? And here, before this closing bracket, we just say hashtag undefined max size. Let's try printing it out. So we say printf %d, comma, max size. Right, so now let's run this. Max size undeclared. You can see that because we have undefined this, it's not going to print. But now if I comment this out and if I say max size is, and now if we run this, and you can see max size is 5, right? So you know how that works. Moving on. Talking now about the line directive. As I said, the line directive has something to do with line control. So let's understand line control. Let's say we have source program A, we have source program B. Preprocessing output of both files is directed to an intermediate file before, of course, being presented for compilation. Now, as you can understand, the line numbers are going to change, and it is the line directive that actually changes the values of these predefined macro names. We have _line or _line. We have _file, _date, and _time. And line directive will change the contents of _line and _file. Right, now this is very useful in debugging, because imagine if you have a huge project and you're combining the source code of many files into one intermediate file. Then you come to know through the compiler, because remember, this line directive is sending these messages to the compiler, right? So after compilation, you get to know which line was being compiled in which file, right? So just to show you a very simple example, because we don't have really a big project here, but it would be something like this. Right, so we have file being compiled, date of compilation, and you can see we're using those predefined macros there. And we have line being compiled. Now we could also have the function name, right? If I run this now, you see that I get the file name along with the path to the file, the date of compilation, the function name, and the line being compiled. And as I said, this is more relevant and will be more appreciated when there are more than one source code file combined into an intermediate file. Right, so moving on now. Comments. No spaces between / and asterisk. I think we know that already. Single line comments can begin with 2 /. We can't have something like this where, the comment is in the middle of an arithmetic calculation. Comments cannot be nested. What's important to remember that all functions should have comments indicating what the function does, a description of the arguments it uses, and what it returns. Very important for documentation purposes, because remember, your code may be used by many programmers after you, right? This ends our session for today. In the next session, we look at the C standard library, and we'll also, if we have time, discuss a few input-output functions that we've not seen earlier. So till then, take care, stay safe. Bye.